Hey guys, Tutoring's Pause Maths Labs here today, and today we're going to be looking at Pythagoras Theorem, and we're going to be looking at finding the shortest side of a right-angled triangle. Okay, so we're going to be looking at this today, finding the shorter side of a right-angled triangle when given the hypotenuse, which is the longest side, and one of the other shorter sides. Okay, so without further ado, let's get started. Okay, so we're going to look at this question first. So let's call this side is which we're looking for. Let's call this side our A. Okay, so this is our A, our shorter side that we are looking for. So the right angle triangle has got two shorter sides. One of them is 6 and the other one is A. Okay, and I should really put A centimeters because our units are in centimeters. Okay, so A is going to be equal to the square roots of our longest side squared, which is 10 squared, take away 6 squared. Okay, so A is going to be equal to 10 squared is 100, 6 squared is 36. Okay, so A is going to be equal to square roots of 64, and A is therefore going to be equal to 8. Lovely, very, very easy, simple. 8 centimeters, shall I say. Lovely. Okay, now let's move on to this one here. We're going to move on to this question now. So we've got 17 centimeters and 8 centimeters. Our longest side is 17 centimeters, and we're trying to look for one of the other smaller sides. So let's call it A again. So we're going to say A is equal to the square root of 17 squared, take away 8 squared. Okay. Squared. Now I'm going to do this on the calculator very, very quickly. 17 squared take away 8 squared. 17 squared take away 8 squared is going to give us 225. So 225. Okay. And then we're going to look at the square roots of 225, which is 15. Okay. So therefore our A is equal to 15. Okay. And that makes sense because these two sides, this side and this side, have to be the shorter side. So you know that their values are going to be smaller than the longest side, which is 17 centimeters. Okay, so it fits that A should be 15. Now we're going to look at one more example down here. So we've got our hypotenuse, which is 26 centimeters. So that's the hypotenuse. The longest side is 26 centimeters. And you always know the hypotenuse is always opposite of the right angle. It's the side always opposite of the right angle. So you got the right angle there. You got the right angle there, and opposite of the right angle is the hypotenuse. Okay. So anyway, we're trying to look for A, which is this side here. Okay. So again, we're going to say A is equal to the square root of 26 squared, take away 10 squared. Okay. So A is going to be equal to 26 squared, take away 10 squared. Take away 10 squared is going to give us 576. Okay, so that's going to give us 576. So A is going to be the square root of 576, which is 24. Okay, and don't forget our units is in centimeters. Beautiful. Okay, so guys, that's basically how to find the shorter side using Pythagoras theorem of a right angle triangle. So in order to find the shorter side, what you need, well, first off, you need two lengths. You need one of them is going to be the hypotenuse, the side opposite of the right angle, and just one of the other smaller sides. Okay, and that can help you. Having those two sides will help you to find the other shorter side, and then we can plug it into our formula here, which is A is equal to the square root of C squared minus B squared, where C squared is meant to basically be the hypotenuse squared, take away the other shorter side squared. Okay, well guys, I hope you understood that, and I hope you found that very, very helpful. Thank you for tuning in to Pause Maths Labs, and I'll see you guys later.